Okay, so this is our last homework. I'm just gonna give myself another blank page. So there's basically 8 questions of very similar kinds. So we'll do all of them, but we're going to get quicker and quicker as we go along. So we're going to start with 29. 0.1 moles per liter NaCl, 0.0034 moles per liter lead nitrate. Okay, so NaCl, lead nitrate. I think I can do a couple. Do I have room? I'm going to do a couple here. So there's 2 equations that we write straight off the bat. We have our NaCl plus lead nitrate. So this is just to kind of figure out what salts we are forming as our products, right? So here we have sodium nitrate plus lead chloride, and we know that our lead chloride is our solid precipitate. So we take that information and we use that in our next step where we say lead chloride solid precipitate is in equilibrium with its ions. And we basically want to find the QSP. So we need to find initial what concentrations of lead and chloride ions do I have, and is that enough to form a precipitate or not? So concentration of lead ions first is going to be equal to my concentration of PbNO3 because that's a 1:1 ratio, and that is basically a dilution calculation. 0.034 moles per liter. There is no dilution calculation. Oh, that's nice. There's no volumes given. So these are already my final concentrations in solution. So that's just 0.0034. Concentration of Cl minus equals concentration of sodium chloride, 1:1. To 0.15. So I already have my concentrations here, 0.15, 0.0034, and I'm going to get QSP is 0.0034 times 0.15 squared, because there's a 2 there, which is equal to 7.65 times 10 to the power -5. KSP is 1.7 times 10 to the power -5, so my QSP is greater than my KSP. What that means is these values that I have here are too high. 0.0 is too high because my QSP is too great, so to maintain equilibrium I will shift to the left, and to the left I form my precipitate. So precipitate will form, that's a check. So again, let's do another question. 1 drop of potassium chromate is added to that many thingamajigs of silver nitrate. Does a precipitate form? Interesting question. Okay, same. First we write our double displacement reaction. I think blank page for this. Potassium chromate. This is not, oh, it works. What did I say again? Silver nitrate plus potassium chromate, double displacement reaction. There. Silver chromate plus potassium nitrate. Do I have to balance this guy? I think so. I think I need a 2 here and a 2 there. I should be good. But okay, basically what I'm interested in now is in my Ag2CO3. So I'm going to write the dissociation equation of that guy, because this is going to be my solid precipitate that could form. I have to figure out whether it does form. Okay, so now again I need initial concentrations of Ag and this guy. So I find that from my expression right here. Initial concentration of Ag is equal to initial concentration of AgNO3. Oh, I hate OneDrive. Okay, because again AgNO3 is dissociating into Ag plus and NO3 minus in a 1:1 ratio. 1:1 here, or 2:2. You get the idea. The same ratio, so the concentrations are the same, and my concentration of AgNO3 was 250 milliliters, 0.1 moles per liter AgNO3. So here again, I could do a potential dilution, but we'll do a dilution. Because technically I am adding two volumes. So 0.1 times 0.25 divided by 0.25 plus whatever that minuscule volume was. 0.05 milliliters. Oh, milliliters, so 0.0 liters. So this is basically going to be 0.1 molar. Okay, 1.5 times 0.05. My new concentration of this is 3 times 10 to the power molars, because again I've done a dilution. I've had to take concentration times volume divide by new total volume to give me my new concentration. Total new volume. Right, and I think I did that. Number of zeros are correct. I might be having one extra zero here, but I did the calculations right, so that's that. I hope. And so we take these volumes and we're going to put them in here. 0.1, 3 times 10 to the power negative 4, QSP 0.1 squared times 3 times 10 to the power negative 4. Is 3 times 10 to the power negative 6 moles per liter. And we're going to compare that with our KSP. KSP is 10 to the negative 12, which is very, whoops, undo, I can't undo. Oh well, we don't need that. KSP, or QSP is greater than KSP, and therefore a precipitate will form. That means there's too many ions present because my QSP is too high. Oh, I lost that. Where were we? I don't know. There were too many ions present, so my reaction had to switch left, or move to the left where there was a solid precipitate waiting to form over there. So that's why a precipitate will form. So, let's see here. Sorry about that. Okay, so the next question is a little bit weirder, but also it makes life easier. So we're adding this many moles or this many grams of calcium chloride to 5 times 10 to the power 2 milliliters of this many moles per liter sodium carbonate does a precipitate of calcium carbonate form. So we have to, again, our equation is going to be here and say, whoops, calcium carbonate plus sodium carbonate, calcium chloride plus sodium carbonate is going to give me calcium carbonate solid precipitate plus sodium chloride. And again, as always, I have to essentially find my number of moles of calcium carbonate. So my second reaction is calcium carbonate solid dissociating into calcium ions plus carbonate ions. The KSP of this reaction is, might as well write it from back of the textbook, 3.36 times 10 to the power negative 9. Okay, again, what is my initial concentration of calcium and carbonate? I have to find those things. Initial, again, I don't really need these, I just need to figure out which solid precipitate I would write my second equation for. My initial concentration of calcium 2 plus is equal to my initial concentration of calcium carbonate. I'm given mass of calcium carbonate, as I recall, 0.01 grams, divided by 1 mole. And what is the molar mass of calcium carbonate? Molar mass of calcium chloride, sorry. I keep saying calcium carbonate for some reason. Calcium chloride, 110.98 grams. Another bar to convert this into volume, really. And I already have it in moles, so I just have to divide by my liters, which is 500 milliliters, 0.5 liters. So that is 0. Divided by 110.98 divided by 0.5 is 1.8 times 10 to the negative 4 moles per liter. And I will find my concentration of carbonate, which equals to concentration of sodium carbonate, which is basically equal to 0.0015 mole per liter. Is that the same? No, 0.0015 moles per liter. And that doesn't change, really. So my calcium here is 1.8 times 10 to the negative 4. And carbonate is 0.0015. To calculate QSP, I just have to multiply these because there's no coefficients here, so there's no power. So this is just equal to 1.8 times 10 to the negative 4 times 0.0015. 2.703 times 10 to the negative 7 is my QSP, which is greater than KSP, therefore precipitate will form. No space? I do. Last question on here is the exact same question. Magnesium chloride, sodium hydroxide. I mean, it's not the exact, you know what I mean. It's a similar type of question. Magnesium hydroxide is the solid precipitate we are concerned with. So I'm going to write that. Here, again, I need my concentration of magnesium, which is equal to my concentration of magnesium chloride, which is basically given by 10 milligrams. Oh my god, it's making life more difficult for me. 0.1 times 10 to the power negative 3 grams, 1 mole. What is magnesium chloride? 95.21 divided by how many liters? 0.001. Oh, no. 225, 250. 0.25 liters is 0.1 times 10 to the power negative 3 divided by 95.21 divided by 0.25 is 4.2 times 10 to the power negative 6. Concentration of hydroxide ions is equal to the concentration of sodium hydroxide, which is equal to 0.001. So again, magnesium is 4.2 times 10 to the power negative 6, 0.001. So my QSP is 4.2 times 10 to the power negative 6 times 0.001 squared, which is 4.2 times 10 to the negative 12. But my KSP for magnesium hydroxide happens to be 5.6 times 10 to the negative 12. So here my QSP is actually lesser than my KSP, which means that no precipitate will form, because these values are too less. Because my QSP is less, these concentration values are too less. So even if I add a little bit more magnesium hydroxide, I'll still dissociate into my ions. The equilibrium lies essentially, at equilibrium, if we're comparing, it lies mostly to the equilibrium essentially implies a saturated solution, and this is not saturated yet, so there'll be no precipitate that is forming because it's not saturated. Okay, so I will again remove this because I think we have some more questions to do. What page is this? 446. Okay, we're gonna do this, I guess, next video, or last 447.